Hello, welcome to your pre-lesson video today on rational expressions and equations. We'll get started right ahead because we have a lot to cover. All right, so with simplifying radicals, I'm going to teach you two methods to solve it. You could use either one, which depending on which one you feel more comfortable using. All right. So with the first method, let's look. We have square root 72, and what we're going to do here is we are going to find the factors of 72. So let's list them out as pairs. So 1 times 72, 2 times 36, 3 times 24, 4 times 18, 6 times 12, and 8 times 9. Now I would want to take the pair of factors that has the biggest perfect square. So in this case, it will be 2 and 36, right? So we look here, we have square root 36 times square root 2, right? Because then 36 times 2 is 72. That would equal to square root 36 is 6. This can't be simplified, so we're just going to leave it as it is. And that will be our answer, right? So this is one method that you can use to find to simplify the radical. Or the other method that we can use is the tree method, right? So it's pretty much the same thing except that you would just slowly write down all of the factors of 72 into their prime number. So essentially you're prime factorizing it, right? So let's see, I'm going to pick 3 and 24. From here, let's break it down even more. We got 6 and 4. The only reason I'm not breaking down 3 anymore because it's only going to be 1 and 3, right? And so that's fine. So we'll just leave it as this. Now 24 can break it down because it still has multiples. Now let's break this down. 6 will become 3 and 2. 4 is 2 and 2. All right. Now if we look here, because it's a square root, right? We want the numbers that are repeated twice here to be written here. So let's circle them. We have 3, and we have 2. All right. So we're going to write 3 times 2 times, and then whatever number that wasn't repeated, like this 2 here didn't get repeated, we're just going to write it back in the square root. So square root 2. All right. From there, we will perform the basic operation. So we get 6 square root 2. And that's the answer. All right. Now we look at the bottom. We get a little bit more practice. Now it's with a cube root. This time we need to simplify cube root x to the power 6, right? Here, really short method also is you could do, you're going to take the exponent inside and divide it with the number, the root that's outside. So 3. So 6 divided by 3 equals 2, right? That means I can write my simplified term of this, expression of this as x squared, all right? Now again, the other method that we can use here also is the tree method, and this is how you do it, all right? I know that x squared times x to the power 4 will equal x6. From here, we can break it down to x and x again. Here is x squared, and then these can be broken down more also. Can you see that? Now, because it's cube, that means I need my numbers to be repeated 3 times. So let's circle it. 1, 2, 3. These are repeated 3 times. One group of 3. 1, 2, 3. Another group of 3. So essentially now we have 2 groups of 3, which means we can write it as x squared. All right, and that'll be our answer because there are 2 groups of 3. So imagine like if this is 5, then you will want all your terms here to repeat it by 5. And since like, for example, if this was 5, then we would have 1, 2, 3, 4, 5, one group of 5 only, that kind of stuff. All right. Now I'm going to show you at the bottom how we, if we use like the dividing method on how to write the solution if we have a denominator, right? So let's simplify cube root x to the power of 14, right? So I'm going to do 14 divided by 3. I know 3 can go into 14 4 times, right? So like this. From here, I know 2. Because it's the denominator, I'm going to leave it back in the in the cube root, right? So it's going to be cube root x squared, and then this, the number that is on top, will be outside. So it'll be x to the power of 4, all right? From there, I'm going to write my answer as x to the power of 4 cube root x squared. That will be the solution. All right, if you have any questions on how to simplify radicals, bring it to your deep dive lesson. Now, with multiplying radicals, as you can see, if both of them have the same root number, then the insides will be able to multiply with each other like normal. So if let's say this is square root 1 and this is square root 2, then what you would be able to do is square root 1 times 2, right, which will give you square root 2 in that case. All right, so but let's say this is cube root a and square root b. You wouldn't be able to do anything because this is a 3 and this is a 2, right? So they're like different species. Again, you want the same species in order to do this. So let's practice with this. Cube root 12 times cube root 6 is equivalent to cube root 12 times 6, which is going to be cube root 72. All right, now from here I'm going to check if 72 can actually be simplified any further. So 72, let's break it down using the tree method. Now let's see, because it's a cube root, I need my numbers to repeat it 3 times. So the only one that's repeated 3 times is 2. So let's see. We will write it as 2 cube root, and then since these two numbers were not repeated 3 times, we're going to multiply them with each other. So you get 3 times 3, 9. All right, so that's why your answer is going to be 2 because you have one group of 3 in 2, cube root 9 because 3 times 3. All right. Now we look at this one. Let's multiply them. So 3 square root 6 times 5 square root 2 equals 2. Now coefficients, we can multiply them like normal. So we have 3 times 5 times, and because these roots are the same thing, they have the same number, we can multiply the insides. So square root 6 times 2. From there, we will get 15 square root 12. Let's check and see if 12 can be simplified any further. All right, so we have 12, break it down, 2 and 6, 2 and 3. All right, and then let's see, because it's square root, so I just need my numbers to repeat it twice. So in this case, 2. Therefore, I can write it as 15 times 2 square root 3, right, because 3 wasn't repeated, equals to 15 times 2 is 30. So my final answer will be 30 square root 3. All right. Now, we have a negative coefficient. Again, you want to be really careful when you have a negative coefficient, right? Because it will affect your digit. So let's set up the equation. All right, from here, let's see. We have negative 3 times 5 times cube root 4 times 16. And then, oh look, we have variables, and because the variables are multiplying with each other, we're going to add the exponents, right? So that's why we have y to the power of 2 plus 1 equals to negative 15 times square root cube root 64y cube. All right, and then actually, if you notice, 64, if we simplify it, would be, let's see, this is, because these are repeated 3 times, that means it's going to be negative 15 times 4 times, and I immediately know cube root of y to the power of 3 is going to be y. So once we multiply all this together, we're going to get negative 60y as our answer. All right? And that's how you multiply radicals. Now with this one, we have to distribute the parentheses first. So let's look. Let's write out our equation as usual. Now distribute your parentheses. So 5 times 3 is going to be 15. And then let's look, 2x times x is going to be 2x squared. Now 5 times negative 1 is going to be negative 5. 2x times 2x is going to be 4x squared. All right. Now from here, I am going to break this all down into their parts, as you can see in a second. It's just easier to see it if you break it down like this. Now from here, let's go ahead and square root whatever we can. All right, this could be square rooted to give us x. This can be square rooted to give us 2, and this can be square rooted to give us x. And from here, let's complete it all the way. So our final solution would be 15x square root 2 minus 10x. All right. Now for this one, because we have to square the parentheses twice, let's write it out so we can see what we would need to do. All right, so it's just multiplying with itself. From here, let's see. Square root x times square root x is going to be square root x squared. Square root x times negative 5 square root y is going to give us negative 5 square root xy. Same thing over here, another negative 5 square root xy. Negative 5 square root y times negative 5 square root y is going to give us positive 25 square root y squared. All right, now from here, let's group the like terms and square root whatever we can square root. So this can be square root to give us x. This can be square rooted, but you can group them because they are like terms, right? Because if you look at square root xy, this also has square root xy, which means that they are the same species. So you can group them together to give us negative 10 square root xy. Right here, we can see that y squared can be square rooted to give us y multiplied out with 25, and you would get 25y. Therefore, the solution to this problem is going to be x minus 10 square root xy plus 25y. All right. Now, this one is when we are multiplying the factors together that are conjugates of each other. So conjugate would mean like the sign of the second term is the opposite of the other. So like this is positive square root 3, this is negative square root 3. So we would consider these conjugates. Now from here, we are going to multiply them like how we have been doing. All right. So from here, let's see, square root 10 times square root 10, square root 100. Square root 10 times negative square root 3 is going to give us negative square root 30. Square root 3 times square root 10 is positive square root 30. Square root 3 times negative square root 3 is going to give us negative square root 9. From here, let's group all the like terms and square whatever we can square. So with this, we'll get 10. These two cancel out each other. And then this becomes 3. Now we have 10 minus 3, which will give our final solution of 7. Alright, and that's how you solve multiplication of radicals. Now, with dividing radicals, it is also very similar to multiplying it, right? As long as your radical sign here, or the number, is the same for top and bottom, right? If this is n and this is n, they can just do a divided by b, like this. Alright, so let's look at this example. We have cube root 96 divided by cube root 6. Because they are both cube roots, I can just put them all under one roof, right? So like this. From here, when I divide it, I find out that I will get cube root 16. From here, let's see if I can simplify 16 any further. So I'm going to split it up. We've got 2 and 8 here, 2 and 4, 2 and 2. All right. So that means I get 2, 2, 2. So I have one group of 3 2's. So I'll write 2 cube root. This 2 didn't get repeated, so 2. And that will be my answer. All right. Now for the next one. Oh, it looks a lot more complicated just because there are a lot more variables in there. Fret not, it's actually not as bad as it looks like. So let's see, we have square root 50x to the power of 6, y to the power of 4, divided by square root 8x to the power of 3, y, right? Because they both are square roots, let's put them all under one roof. That looks like a B, there we go. And because we have exponents, we're just going to be, because of the quotient rule, we're just only going to be subtracting the exponents together, right? So how that's all going to look like, let's see. We're actually going to do 50 divided by 80 first, like normal, so that's going to give us 25 over 4. And then we have x 6 minus 3 to the power of 6 minus 3, y to the power of 4 minus 1, right? And then let's simplify it from there. We will get 25 over 4, x to the power of 3, y to the power of 3. And then let's see, let's separate them so we can see how we can simplify them. For this one, I'm going to use the divide method, and I know 3 divided by 2 is going to give me a remainder 1. So I'm just going to write it on the side here. That means at the end, I'm going to get, this will give me 5 over 2. I'll get 1x and also 1y, right? Square root x, y, because of the remainders. And so this will be the answer. All right, if you have any questions about this one, bring it to your deep dive lesson. Now for this one, So this one is a little bit different just because if you look at it, you will be thinking, I can't actually do anything else. It looks like everything has to be simplified. Normally, we want to have the denominator not be in a radical form. So what we would need to do to get rid of the radical form is to multiply the top and the bottom with the radical form that we're given, right? Since it's not being added or subtracted, if anything, we're just going to take this as it is, and you'll understand what I mean in the next question that we are going to do later. So we're going to multiply the top and bottom with square root 6ab. That's going to give us 3a square root 12ab over square root 36a squared b squared. All right. Now from here, I know this can actually be broken down further. So we have 3a times square root 4 square root 3ab. These all can be simplified further, so we're going to get 6ab. From here, this is 2. So we have, let's see, 2 times 3. So 6a square root 3ab over 6ab. Oh, look, we have 6a here and 6a here, so they can cross out each other and simplify. And this is the only thing we have left. Now, we can't cross out b because this b is under the square root, and this b doesn't have a square root. So they're different, so we can't just cross them out. Therefore, our answer is going to be square root 3ab over b. All right, make sure the square root sign is not covering all the way down because that is very different from, because this is very different from this. We don't want that for this solution. We want this. All right. Now, the next thing we are going to do is still dividing radicals, but this time it's a little bit different from the one that we just did above. Now, if we look here, our bottom is 2 radicals with a plus sign here. In order to solve and make sure that the bottom does not have a radical sign, we would need to multiply the top and the bottom with the conjugate of this, right? And so the conjugate of this would just be the change of sign of the second term. So in this case, it will be square root 2 minus square root 6. And we're going to multiply this to the top and bottom of the fraction. From here, we are going to get square root 20 minus square root 60 divided by square root 4 minus square root 12 plus square root 12 minus square root 36. And now let's break it down as much as we can. Let's see, I know these two can be simplified further, so let's do the tree diagram. So 20 is like 2 and 10, 2 and 5, so these two. So we'll get 2 square root 5 minus 60 is, let's do 6 and 10, we got 3 and 2, 2 and 5. Again, 2 is repeated, so we are going to get 2 square root 15. These two will multiply with each other since they weren't repeated. Bottom, let's simplify and group whatever we can. So we'll get 2 negative square root 12 plus square root 12 will cancel out of each other, and then this will become negative 6. All right. From here, we can't do anything to the top since square root 5 and square root 15 are different species. All right, so we have 2 square root 5 minus 2 square root 15 divided by negative 4. And if you look, 2, negative 2, and negative 4, we can actually simplify this because all these can be divided by 2. So therefore, our final solution is going to be square root 5 minus square root 15 divided by negative 2. And this will be the solution. All right. Now again, more practicing with multiplying with the conjugates, this time with variables. So let's write it out. Let's look. Again, like I said, because of the bottom, we want to multiply the top and the bottom with the conjugate of the bottom, which would be, actually let's put parentheses around these. Okay, so the conjugate of this will be square root x minus square root y. And we'll do this to the top and bottom. Once we multiply and distribute everything, we are going to get square root x squared minus square root xy minus square root xy plus square root y squared divided by square root x squared minus square root xy plus square root xy minus square root y squared. Now let's simplify and group the top and bottom as much as we can respectively, right? So from here we are going to get x minus 2 square root xy plus y divided by x minus y. And this will be our solution. All right. If you have any questions about dividing radicals, I know this was a lot. Bring it to your deep dive lesson. All right. Now, adding and subtracting radicals. If you look at this, the first thing that you might think is, oh, I can't do anything else, right? What you actually want to first do is break these all down because you can simplify them. So let's look at 50. If we break it down, we get, let's see. So with 50, we get 3 times 5 square root 2 minus, let's look at 8. Let's write 8 here. 2, 4, 2, 2. So we have 2 times 2 square root 2 minus, let's look at 32. We have two groups of 2. All right. So we know that's going to, so 2 times 2 is going to be 4. So let's do, we have 5 times 4 because 2 times 2. And then square root 2 because this 2 wasn't repeated. Now let's simplify all this. We get 15 square root 2 minus 4 square root 2 minus 20 square root 2. Oh look, they all have square root 2, which means they're all the same species. So let's group the coefficients together. So 15 minus 4 minus 20 is going to give us negative 9 square root 2. And that is going to be our answer. Alright, now if we look at the bottom, oh no, a fraction. It's actually not too scary. Alright, so let's look. We're going to write 4 like normal first, and then parentheses. Let's break down 20, because I already know that 9, square root of 9 is 3. So 20, let's see how much we can break down. Alright, so we're going to get 2 to the power of 5 divided by 3, because of the 9, close parentheses, plus 5. Let's see what we can get with 45. There we go. So with 49, we will get 3 square root 5 divided by, and then square root of 16 is 4. All right. Then from here, Let's multiply our coefficients. So we're going to get 8 square root 5 over 3 plus 5 times 3 is 15, so 15 square root 5 divided by 4. All right, now we're not done here. We can actually still simplify this even further because we can find the common denominator, right? And I know the common denominator for 3 and 4 is 12. So let's multiply top and bottom here with 4 and top and bottom here with 3. So we're now going to get 32 square root 5 plus 45 square root 5 over 12. All right, now from here, because they are both square root 5, which means they're the same species. So we can just add the coefficients, which are 32 plus 45, to give us 77 square root 5 over 12. And that will be the answer. All right, not too scary. Now, same thing again, but with subtractions, and just a little bit more careful because it is subtraction. All right, let's look. We have 6. Let's look, how can we break down 24? 24, la 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 la. So let's look. We have 2 square root 3 times 2, 6. And I know square root of x to the power of 4 is going to give me x squared. Minus 3. Let's break down 54. Which is going to give us, let's see. It's going to give us 3 square root 6 over, again, x squared. Multiply our fractions. We are going to get 12 square root 6 over x squared minus 9 square root 6 over x squared. Oh look, common denominator, so we can just group them together and operate on them, right? And look, square root 6, square root 6, same species, so we can just take the coefficients, 12 minus 9, to give us 3 square root 6 over x squared, and that'll be the solution. All right. All right, so if you have any questions about adding and subtracting radicals, bring it to your deep dive lesson. Now with FOILing with radicals, again, you want to multiply everything together. So let's first do this. Let's do 2 times 3 first, which would give us 6. Then 2 times negative square root 5 is going to give us negative 2 square root 5. And then from here, we're going to do square root 5 times 3, which is going to give us positive 3 square root 5. Square root 5 times negative square root 5 is going to give us negative square root 25. Now let's group and simplify all that we can here, which in this case would be, let's see, 6 can't be done anything yet, so we'll just drop it down. Same species, so we can group them, which would give us positive square root 5. And then this I know would give us 5, so it'll be negative 5. And then 6 and negative 5 now are the same species, so we can group them together to give us 1 plus square root 5, and that will be the answer. All right. Now, if you look at this one, we are going to be multiplying the parentheses, the factor by itself. All right, so we set it up. Will be square root 2 plus square root 7 times square root 2 plus square root 7. So square root 2 times square root 2 is going to give us square root 4. Square root 2 plus square root 7 is going to give us square root 14. Same thing here. Square root 7 times square root 7 is going to give us square root 49. Now let's simplify and group the like terms that we can do. This will become 2 like terms, so we have 2 square root 14. We can simplify this to give us 7. Group the like terms together, so 2 plus 7 is 9. This doesn't have anything that we can do anymore. So it'll be 9 plus 2 over 14. And then actually, let's see if we can simplify 14 any further. So 14, we have 2 and 7. Yep, so that'll be it. You won't be able to simplify this, right? Because this is all that we have and nothing can be repeated. So this will be its final solution. Alrighty, now with radical equations. So in order to solve radical equations, it is a little tricky, but it takes a lot of practice, right? So we need to get rid of the radical sign. In this case, the first thing that we are going to do is we are going to square both sides of the equation. Now 2x to the power of 2 is going to give us 4x squared. When we square this, so we have a square root and we're squaring it, we're just going to get rid of the square root. So it's going to be x plus 3. Oh, look. Exponent of 2. Let's bring everything to one side. So we're going to get 4x squared minus x minus 3 equals 0. From here, I am going to test it out using the butterfly method. Let's see. Okay, it looks like it works, so that means my factors are going to be 4x plus 3 and x minus 1 equals 0. From here, I'm going to find out what x would equal to. Right, so x equals negative 3 over 4, and x equals negative, and x equals 1. Now, we're actually not done yet because with this method, which is the only method you can use anyways, there's a side effect where you will get a solution that would not satisfy it. So we actually got to test out both of these to see if it satisfies. So let's look. When x is negative 3 over 4, let's plug it into both x's. So we have 2, 3 over 4 equals the square root negative 3 over 4 plus 3. Now on here, once we solve everything, we are going to get negative 3 over 2. Once we solve everything here, we're going to get 3 over 2. But look, negative 3 over 2 is 3 over 2. That doesn't make sense, right? So they don't equal to each other, which means we're going to reject this solution. Now let's check the other one. So when x equals 1, we have 2 times 1 equals the square root 1 plus 3. This will equal to 2, and this will equal to 2, which means it's okay and satisfies the solution, the equation. Therefore, our answer is x equals 1. We have only one solution. All right. Now look, oh, we have 7 by itself, and then we have negative x over here, but it's not under the square root. So first thing we would need to do is bring this negative x over here. And so we're going to add x to both sides of the equation. So we're going to get 7 plus x equals to square root 39 plus 3x. From here, I need to get rid of the square root sign, so I'm going to multiply, I'm going to square both sides of my equation. All right, from here, once I FOIL my parentheses, I'm going to get x squared plus 14x plus 49 equals to 39 plus 3x. From here, let's bring everything to one side of the equation so that we can factor it. All right, so from here, we're going to get x squared plus 11x plus 10 equals 0. Again, butterfly method. trial and error. Let's see. Yep, that will work. All right. Alrighty, so that means our factors are going to be x plus 10 and x plus 1 equals 0, x plus 10 equals 0, or x plus 1 equals 0. We'll get x equals negative 10 and x equals negative 1. Again, we would need to trial and error here, so let's look. When x equals negative 10, what would we get? Let's see. So we have 7 equals square root 39 plus 3 times negative 10 minus negative 10. Once we solve everything on this side, so just plug it into a calculator, you'll get, let's see, this will give us 3 plus 10, 7 equals 13. But wait, 7 is 7 and 13 is 13. 7 is not 13, so that means this is false. So we're going to reject this solution. Now let's try when x is negative 1. Alright, plug it in again. Oh look, 7 is 7. So that's correct. So that means our solution to this is x equals to negative 1. Alright? Alrighty, on to our very last question. Thank you for staying tuned all this while. Alright, so first thing we're going to do here is, because both sides have a square root sign, I'm just going to straight away square both sides and see what I will get. Alright, so from here I will have to do this. Right, the reason that the square root sign doesn't cancel straight away is because there's a 1 plus here. On the flip side, because this square root sign is by itself, it's not like there's anything to the side of it, we can just immediately take the square root sign away. Alright, now from here, let's FOIL it, which is going to give us 1 plus square root 1 over x plus square root 1 minus x plus 1 minus x equals to 2x plus 4. From here, I am going to also bring these over this side. So from here, we are then going to get, let's see, and we're going to group all the like terms together. So we are now going to get negative 3x minus 2 plus 2 square root 1 minus x. Alright, these are same species, so you just add the coefficients to give you 2 equals 0. Now we want, oh, we still have a square root sign, so we need to get rid of it, right? So let's see, let's get rid of these two so that this will then be by itself. So we're going to add 3x, add 2 to the other side. Yep. Which would then give us 2 square root 1 minus x equals to 3x plus 2. Now from here, because of the square root, again, we would need to square it. Unfortunately, this is the only way to solve this question. Right, from here, we will get 4 times 1 minus x, because of this, equals to, once I FOIL this, I know I'm going to get 9x squared plus 12x, let's write that 12 probably, plus 12x plus 4. distribute this. 4 minus 4x equals 9x squared plus 12x plus 4. Let's group the like terms all onto one side. So let's see, I'm going to bring it this side. So we have 9x squared plus 16x, equals 0. Now from here, oh look, these two have x's, so I can just factor my x out to give me x times 9x plus 16 equals 0, x equals 0, or 9x plus 16 equals 0, x equals to negative 16 over 9. Now again, I need to test my solutions. Alright, so let's hopefully be able to squeeze in a bit here. So, when x equals 0, we get 1 plus 1 minus 0 equals square root 2, 0 plus 4, la 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 la, everything. Once I solve both sides, I'll get 2 equals 2. Okay, accept. Now, when x equals negative 16 over 9, let's plug it all in. Let's write that a little bit more clearly. Just plug it all in and then put it into your calculator. Ooh, I'm running out of space. Bear with me here. Alright, once we put it all into the calculator, we are actually going to get 8 over 3 equals to 2 over 3. But these don't equal to each other, so it's false. We're going to reject this solution. Alright, therefore, our only solution to this radical equation is x equals 0. Alright, and that'll be it. Well, good job everyone for staying tuned to this pre-lesson on radical expressions and equations. Kudos to you guys. Alright, thank you for tuning in. If you have any questions, bring it to your deep dive lesson. Have a good rest of your day.